Hey guys, and welcome to Engineering Fundamentals, an introduction to mechanical engineering. This falls under Principles of Applied Engineering. So mechanical engineering is the designing, building, and maintenance of mechanical and fluid systems. Mechanical engineering is one of the largest, broadest, and oldest engineering disciplines. These engineers work on products that cover a wide range of scale, from designing and producing nanotechnology products at the microscopic level to maintaining large power stations. The education for a mechanical engineer varies. So the entry-level requirement for most mechanical engineers is a bachelor's degree. Most mechanical engineers have degrees in mechanical engineering, but some have degrees in other engineering specialties. To earn a degree in mechanical engineering, courses must be taken in the fundamentals of engineering, statics, dynamics, robotics, mechanics, thermodynamics, calculus, and physics. There are several professional societies available to mechanical engineers. The broadest is the American Society of Mechanical Engineers, or ASME. Mechanical engineers that specialize in vehicle design may choose to belong to the SAE, formerly known as the Society of Automobile Engineers. You can also become a mechanical engineering technician with an associate's degree, and most colleges offer internships into mechanical engineering fields. So when we're talking about mechanical engineering, there are several principles that we need to be aware of. The first one is force. Force is the push or pull of an object resulting from contact with another object. When we close a car door, throw a baseball, or pull a wagon, we use force to move an object. Force can also be classified as the weight of an object. Work is defined as the application of force to move an object a distance. Work only happens while a force is being applied and movement occurs at the same time. Work cannot be accomplished without movement of an object. The formula for work is work equals force times distance. Force applied is movement occurs. While mechanical tools are used to complete work, it is also important to be able to measure the amount of work. To measure and evaluate work, we use the term power. Power is the rate at which work is performed or energy is transmitted and measured in watts. Work and power have some similarities. The formula for power is power equals work divided by time. You must calculate work before you can calculate for power. So the measurements for these different units are: work is measured in joules, force is measured in newtons, the distance is measured in meters, and power is in watts. Now, power can also be measured in horsepower if on larger apparatuses such as engines. So let's do a quick practical exercise on that. So let's calculate for work. So if we're looking at this question, it took 1 Newton of force to lift a book 2 meters. How much work was done? So let's look at the first part of it. So the formula is work equals force times distance. So work equals 1 Newton times 2 meters once we input our numbers. So work is measured in joules. We've got to remember that. So the total number of work equals 2 joules. So that's number one. Let's look at number two. Let's look at another example. So this is a different example. So a force of 15 newtons is used to push a box along a floor distance of 3 meters. How much work was done? So we already know the formula. Work equals force times distance. And so now we're going to input our numbers in there. And so work equals 15 newtons times 3 meters. So total number of work is 45 joules in this example. Let's look at a couple more. So it took 50 joules to push a chair 5 meters across the floor. With what force was the chair pushed? So this is going to be a little bit different. The formula is still the same. Work equals force times distance. So 50 joules equals F times 5M. And now we need to convert that. So it's going to be F equals 50 joules divided by 5 meters. And so our total amount of force in this example is going to be 10 newtons. And we have one more example. So a student who weighs 500 newtons climbed the stairs from the first floor to the third floor in 20 seconds. There's two questions to this. How much work did she do? And what was her power? And so we know the formula for work is force times distance. So we're going to do work equals 500 newtons times 15 meters equals 7,500 joules of work. That was our first part. Now we need to figure out what the power. This is the first time we've done this. So power equals work divided by time. We know that we have all the answers that we need to be able to figure this out. So power equals 7,500 joules divided by 20 seconds equals 375 watts. So here's 4 examples for you on how to calculate for work, how to calculate for force, and how to calculate for power. And so in conclusion, this is the first part of our introduction to mechanical engineering. We've talked about the education. We've talked about kind of what mechanical engineering is, and we've talked about some of the simple formulas that are used to calculate for work and power. So work has a special meaning in engineering. It is the product of the force applied to an object and the distance the object moves. Power is the amount of work divided by the time. You must calculate work first. Power is measured in watts in lower output devices such as human work output, and horsepower in higher output devices such as engines. In our upcoming lessons, we will be talking about how to calculate for horsepower, and we'll also be talking about how to calculate for work in fluid measurements, right? So fluid outputs. Hope you guys enjoyed this lesson. Please look back on it. If you have any questions, please let your instructor know, and have a great day.